Hello and welcome back. Thanks again for joining us. Very excited to kick off this next session, which will be the last session for this track today, and wrapping up this channel for Forward 50 this afternoon. Vic Pant is the Chief Scientist and Chief Science Advisor at Natural Resources Canada, and he is going to be introducing us to a framework for aligning investments in data and digital with public sector priorities and plans. So please welcome Vic Pant.
Hi, everybody. Welcome to my session at Forward 50. It's my pleasure to talk about the alignment between artificial intelligence investments with organizational mission and mandate, strategic priorities and plans. My name is Vic Pant. I'm the Chief Scientist and Chief Science Advisor at Natural Resources Canada, and I'm thrilled to be here at Forward 50 and would like to especially thank Rebecca and Alistair and the entire organizing team for bringing us together to share these important ideas in a safe and inclusive space. This is a very important topic in our department and in my consultations with our partners within the public sector and in the private sector. This is a topic that really there's a lot of opportunities for collaboration and partnering on. This whole notion of the co-creation of value, the understanding of how value is generated by artificial intelligence solutions and data science applications within enterprises, and really just even the notion of value, period. What do we mean when we talk about value coming from investments in data and digital solutions that these artificial intelligence applications and packages are really about? At Natural Resources Canada, just to take a bit of a step back, we are an organization within the Canadian federal government. We are a ministry, and our focus is on ensuring that our natural resources in Canada are developed in a manner that is responsible, sustainable, and innovative, recognizing that our sectors in energy, forestry, and mining operate in a global marketplace, and ensuring that Canadians can benefit from our abundant natural resources while also ensuring that we are good stewards and good shepherds of these resources into the future. Now, this notion of artificial intelligence and aligning with organizational mission and mandate is very important. When you think about it, when we started looking into this topic, we thought, is it just us that is investing in artificial intelligence, whether it be spending on technology, whether it be building teams, whether it be acquiring data sets, whether it be just creating the time and the space in an enterprise, thinking about opportunity costs to be able to do artificial intelligence and data science in a systematic and scalable manner. And what we realized when we did a bit of a survey and we did some sort of analysis was that many organizations are grappling with this challenge of understanding what the value, what the impact, what the benefit, what the net organizational advantage is of investing in artificial intelligence and data science. That's not to say that organizations are not spending. In fact, quite the contrary. Organizations are hiring big teams. They're doing experimental and exploratory projects. They're even scaling AI in the enterprise, whether you look at retail, whether you look at telco, whether you look in the public sector. But really to understand what work artificial intelligence is doing in the enterprise, that is far from a settled science. That is far from a settled economic even question. And so this is something when we did our research, we found was a challenge that many enterprises were grappling with, and we wanted to take a look at it as well, being that in Natural Resources Canada, we have built up the Digital Accelerator, whose sole purpose is the creative applications of innovative digital technologies, including but not limited to AI and data science, to solve some of the big challenges or to achieve the goals that our enterprise is seeking to accomplish. And so good to know that we are in the company where there is that appetite and there is that interest for enterprises in the private sector, in the public sector, in the academic university research communities to come together and look at AI, not just from a technology perspective, which is looking at the algorithms and looking at the architectures and looking at the various software packages that allow us to do data science in a way that is effective and efficient, but also to look at it from an economic perspective, from a corporate perspective, and say, okay, we're making these investments, but what is the return on these investments? How are these investments paying us back in terms of our organizational mission and mandate and our strategic priorities and plans? So one of the interesting areas of work that we have looked into is we partnered up with the University of Toronto. And at the University of Toronto, Professor Eric Yu's research group, and especially research colleague Surush, who's now over at a software firm, they had looked into this topic from a research perspective, but with a lot of empirical support. So they had built this framework, which is a technical framework with a very strong computer science underpinning that essentially aligned this notion of the design of artificial intelligence solutions and the deployment of AI solutions with the organizational goals, with the strategic priorities that they map to. So this is sort of the starting point that we began our exploration into understanding the value of AI and data science, is to look at the work that they are doing and partner with them to bring some of their knowledge into our department so we can start applying their framework to some of our artificial intelligence investments. So if you're interested, their work is available online. You can find it on their respective websites. You can find some of these papers where the elements that I'm going to discuss in this talk today, you can dive into them in much, much more detail and really take away a lot of actionable insights that you can then apply in your own enterprise as well. So one of the things to think about in this package that's really powerful is that instead of looking at AI or data science purely from a software perspective or purely from a data perspective, they look at it in a hierarchical fashion. So before we start talking about AI as a sort of software package or some kind of a tool that you use that has AI capabilities in it, they take a look at what they call the business view. And the business view says, okay, before we start looking into technology or software or data or digital, let's first start looking at what's our organization's goals? What is our organization trying to achieve in general? Who are the players? Who are the stakeholders? Who are the actors? Who are the participants in our value constellation and our value ecosystem? And how do their goals and their objectives come together in ways that create opportunities for cooperation, but sometimes also lead to situations that could be competitive? So we can think about this as goal modeling. It's to understand the goals of the enterprise at various levels of specification so that we can really understand when we say we're doing X to achieve Y, what is that why? So if we don't know what that why is, then really it's hard to ground investments in any kind of technology to what those higher level objectives of the enterprise are. Once we know what the business goals are, the next level is what they call the analytics design view. But the idea here with analytics design view is, okay, you've got some business goals identified. You know who the players are. You know who the main actors are. You know what their objectives are collectively and individually within the overall value ecosystem, the value constellation of the enterprise. But to achieve those goals, certain insights are required, because in the information age, in modern digital driven economy, we are not simply making decisions guided by our gut feelings or by our intuitions. We're making decisions based on data. We're making decisions based on analyses and insights that are sourced and surfaced from the analysis of information. So when we know what the goals of various players are in the enterprise, then we can start to understand what kind of information needs those stakeholders or those participants have in the enterprise to make those decisions in effective ways. And that's where the analytics design view comes into play, is we start to design software solutions, software packages using AI techniques, using data science algorithms and models and the like to help meet those information needs. But that's not where the story ends, because I think for most of us that are in the field of applied artificial intelligence and advanced analytics and data science, we know that if we don't have data, then we can't really train these kinds of models. So the third piece of this framework is the notion of the data preparation view. And this is where we come in and we say, okay, so to train models at the analytic coming out of the analytics design view that are going to meet our needs in the business view, what are the types of data sets that we need access to? And how do we combine those data sets in meaningful ways? How do we clean those data sets? How do we ensure that there's governance around those data sets? And so that's really where the data preparation view comes into play. So when you think about it, this is a very nice 3-layer framework that can be developed in a very sequential and a component-wise manner so that you can focus at any given point in time in the specific layer of the framework that you're actually working on, but then do so in a way that comes together and you can judge and assess the alignment between all of the different elements of your framework when you apply it in your enterprise to answer that question of, okay, so what is this investment in data, or what is this investment in building training an AI model or deploying some kind of a data science solution help me achieve in the overall organizational context? This is because the business view helps us to understand who needs the AI or data science system that we're building. What are they going to use it for? Why do they need a system such as this? So this gives us that justification, that business grounded rationale for why it is that the investment that is being proposed or an investment that has already been made should be made or has been made. Analytics design view is taking a deeper look and saying, okay, well, based on the information needs, based on the kinds of insights we need to support the decisions which we need to support to meet or exceed our business goals, what kinds of artificial intelligence systems do we need? What kind of canonical tasks do we want to perform? Are we trying to do regression? Are we trying to do clustering? Are we trying to do some type of dimensionality reduction? Are we doing some kind of, let's say, classification? So these are canonical tasks, but within each of them, we have lots and lots of choices in terms of various algorithms. Which kind of algorithm should be used for classification? Which kind of algorithm should be used for regression, for instance? And then thinking about how do we compare them? And in most data science workloads, we have some technical metrics that we use to compare models, and the selection of those technical metrics is grounded in our organization's needs. So when would you look at precision over recall? When would you look at the F1 score over, let's say, accuracy? So there's all of these different choice points, decision forks that data science leaders in organizations go through when they're selecting how they're going to decide which model is outperforming other models. But one of the things that we have found in our enterprises, simply looking at technical metrics is not quite often sufficient. You need to also look at what are called non-functional requirements or quality criteria, which I'll talk about. And so that's what all of the analysis and the reasoning that happens in the analytics design view. And ultimately, now that we know what kind of models we need to train, we can now use that to drive decisions on what kind of data sets we need and what kind of processing needs to happen in those data sets, what kind of engineering and wrangling needs to happen to make sure that the entire stack can deliver value for the enterprise. So the nice thing about this framework is it can be applied top down, it can be applied bottom up or middle out. And the nice thing is that essentially it supports reuse, it supports the ability to break it down into various components and do this in a sequential or a parallelized manner. And so from a work allocation or work distribution perspective, it's a fairly straightforward framework to operationalize, as we are finding in my department. So the next thing I want to talk about is the business view. And the business view, as I've mentioned before, really gets at the why question, or what I like to say, the so what question, right? Is very often in enterprises, investments are made in artificial intelligence, and that's understandable because data science and AI and machine learning, these kinds of tools and techniques have a significant element involved that is exploratory, that is experimental. If you don't experiment, if you don't try various different choices and various different decisions and what kinds of models you're training and how you're training them and what you're training them for, then maybe you're leaving some options on the table, which certainly it is an experimental enterprise in many cases. But if all you're doing is artificial intelligence and data science projects purely from an experimental perspective and an exploratory perspective, sometimes ex post, after the fact, it's hard to map them back to the organizational goals. And when that happens, then certainly folks in the finance side or folks in the investment side of the house in your corporation or your enterprise or your department might start to ask some questions and say, well, it's great that we're doing these types of examples and explorations and experimentation, but at what point will we start to see some tethering, some mapping, some linking with the goals of the enterprise, which ultimately represent the collective or consensus-driven objectives of all of the executives and leaders in the organization. So with the business view, we are neatly bypassing that issue by saying, look, whether you're starting from an exploratory perspective, where you essentially where you have a portfolio of existing data science and artificial intelligence tools you've built in your enterprise, and you want to understand what kinds of objectives in the enterprise they could map to. So you could do that linking as long as you have a well-populated framework representing the business view. Or you can drive it top down, is you can say, okay, these are my organization's goals. What kinds of solutions, what kinds of tools and systems do I need in my enterprise? So here, what the business view allows us to do, this part of the framework, it allows us to look at the stakeholders, the participants, the players, the actors in a value constellation, in a value ecosystem that your organization exists within, what their objectives are, what kinds of decision processes they take, what kinds of questions they typically answer when they're making decisions in the enterprise, as I said, to make decisions based on insights as opposed to intuition, and then also ultimately what kinds of information needs they have, which will then take us to the next level of this, level of this framework, right? So I'll walk you through a very simple example. And the researchers, when they developed this framework, did quite a bit of empirical validation. They went to telecommunications organizations, they went to retailers, they went to a few other places. Also now we've been doing some validation in my department, working from a public sector perspective. So to start the analysis of the value of an artificial intelligence solution or a data science tool in an enterprise, we can start with the business view. And the business view begins with the notion of an actor. Now, in any large organization, you have actors or participants. Decisions are made by consensus. Decisions are made sort of by people coming together and hashing out ideas and choosing courses of action. So we start by deciding who the actors are. Okay. Once we choose who the actors are, we can then start to write in this framework, or start to depict graphically, visually, diagrammatically in this framework what their goals are. So you can think of these goals as the highest level goals as strategies. And we often hear this term sort of in corporate management type context, is this notion of strategy is the high level goals of the enterprise, as well as the high level approaches that the enterprise adopts to achieve those goals. So we have actors. These could be your executives. These could be your leaders. They have certain goals. And so we can map those out nicely in this kind of a visual depiction. But when you have strategic goals, when you have high level goals, to really look at the goals in a fine-grained way, you have to decompose them. You have to break up the goals. I mean, goals in this example, such as improve customer satisfaction, that's just way too high level a goal to be met by, to be sort of satisfied by any kind of technology solution all by itself. So perhaps in this organization, when we talk about improving customer satisfaction, we can break that down into two sub goals or two component strategies. Okay. So one component strategy could be that to improve customer satisfaction, you provide personalized content to e-shoppers, people that come to your e-commerce web front, right? But the other part of achieving this is you can reduce the wait at the checkout line. So if you also happen to operate a bricks and mortar store, this is an example of a grocery retailer, then if you have a website and you have a physical store, then maybe improving customer satisfaction requires these two and perhaps many, many, many other sub-strategies. And each of these then can perhaps be decomposed further and further down, right? So the idea here is you start by understanding who the main actors are, who the main players are. Then we start looking into, okay, what are their main objectives? What are their main strategies? What do they wish to do? We break the strategy up into manageable components, the way that you normally would in an organizational work breakdown structure setting anyway. But then at some point, when we reach a certain level of a goal that can be operationalized, we now reach what's called a decision point. And so a decision point or a decision goal is when we need to start making certain choices. We need to start evaluating certain trade-offs, make some comparisons to select a course of action that will help us to then operationalize that strategy. So in this example, when we talk about reducing the wait at the checkout lines, well, one of the decisions that you can think about when it comes to that specific kind of a goal or a sub goal is decision on staffing levels, right? Or decisions about how many self-checkout lines should we have versus how many assisted checkout lines should we have, and things like that. When you talk about personalizing content for e-shoppers, we can make decisions specifically about, okay, do we want to differentiate by offering coupons? Should we do some kind of bundle selling? Should we do some kind of loyalty card of some kind? So when you have these objectives, to operationalize these objectives, you need to make certain choices. And to make those choices, you have to set these so-called decision goals. Okay. Now, once we set these decision goals, the next thing we want to do is how do we make a decision in an informed way? To make a decision in an informed way, what we can do is ask a series of good questions. Right? So decisions on staffing levels for cashiers, one of the questions we might want to ask is, okay, is there an optimal level of cashiers between this time and this time on this day of the week? Maybe that's something we already know the answer to. Maybe it's an answer we don't know, or maybe the answer changes over time with seasons and all kinds of other things happening in the world. Another question is, how many customers are we expecting at this time of the day, on this day of the week in my store? We may have that question to that answer pat down, but it may be something that changes over time. So these are questions that we need to answer to be able to make the decisions, to be able to then help operationalize the component strategies to help us achieve our organization's overall set of strategies. Okay, these are the questions. And so when we start to represent questions in this framework, the next thing that then comes up is, how do we answer a question? We answer the question based on what we call insights. Because when we answer the question by providing information into that decision process, we can then say, oh, okay, the correct number of people, the cashiers that I need to have in my staff at this time on this day of the week is this. And so there is some kind of information that my judgment is grounded on. And so that is what we call insights. So top to bottom, when you follow the population of this framework or instantiation of this framework in your enterprise, you can start with actors, you can set up the high-level business goals or strategic objectives of the enterprise, you can come down a level and set up some of the decision goals. Based on the decision goals mapping to those strategic objectives, you can identify the question goals. These are phrased as goals because these are things we need to get done in the enterprise. And then the question goals then take us into the decision goals, take us to the question goals, and the question goals then tell us what kind of information is needed to answer those questions. And now for those of us that are in the data science and advanced analytics and applied AI space, this is now getting into our wheelhouse, right? Because now we have the organizational requirements nicely set out for us somewhere. Now we don't have to worry about having to justify why it is we're doing what we're doing. We actually have the stakeholders in the business telling us, hey, these are the kinds of questions we're trying to answer. Here is why, and they can take it up the hierarchy and show us why these questions are relevant. But now when they tell us what kind of questions they're trying to answer, that's where our contributions from an analytics systems design perspective can begin and can get started. Okay, so let's take a look at that. So in the analytics design view, now that we know what kind of goals the organization has and what kind of decisions need to be made to maximize the likelihood of those goals being achieved, then we look at the questions that need to be answered to make meaningful choices and comparisons to answer those, to make those decisions and to make those trade-offs are these question goals, and to answer the questions we need information. And getting of that information is what this analytics design view is all about. So this asks the what question. Remember, previously we were asking the who and the why and the so what question. Now we're asking the what question. Okay, so for me to meet the information needs that have been articulated in the business view, what kind of an AI system do I need to design? So here we're getting into a bit more of the technical nitty-gritty of the solution that will be designed and debugged and developed and deployed so that the organization can create an appropriate organizational value. So here we're looking at the analytical goals, the algorithms, the models, the canonical tasks, the performance metrics, and as I mentioned, very importantly, non-functional requirements, or what are called soft goals. Okay, so let's dive into this a little bit and look into this in a bit more detail. So now remember that in the business view, the strategy has been mapped out, the decision points involved in operationalizing the strategy so as to, in most likelihood, maximize the achievement of that strategic objectives has been articulated, and the question goals linked to those decisions and the insights have been identified. So the output of the business view, you can think about it, becomes the input into the analytics design view. If you're thinking about it sort of in a vertical frame, then what is coming out downwards from the business view is now feeding into the top of the analytics design view. Because after all, as folks in the advanced analytics space and in the data science space and in the applied AI space, what we want are requirements from the business that tells us what kinds of information needs they have so that we can build our solution around those needs. So as you can imagine, once we have coming out of the business view, the needs of the organization articulated as insights or information goals, we can feed that in and we can turn that into, in our framework, what can be called an analytics goal. And so you can think about the analytics goal as what is it that we're trying to do, right? So if in the case of e-commerce, we have an issue in our enterprise with churn or with cart abandonment or people abandoning or sort of terminating their sessions on the browser, then maybe one of the things that we need to understand to meet some of the higher level business goals is we need to build some kind of a churn predictor AI model, or some kind of a data science tool that, given the right kind of inputs, gives us some probability of a customer churning so that we can try to make an offer to them and make their experience a bit more sticky and keep them in that buying process for longer. Okay, so the analytics goal to map with some kind of an information goal, as I mentioned, or an insight requirement in the business view, at the highest level, we have this analytics goal. But this analytics goal itself can then be met by multiple different technical alternatives, technical options. So are we trying to do a prediction, but is this prediction something more like a regression problem? Is this prediction more like a classification problem? Is this prediction more like a clustering problem? So things like that. So you'll see right below predict, we have this notion of classification that you can think about as a canonical task. But when we get into a canonical task, there are many choices of possible algorithms, right? So if we're going to do classification, we can use support vector machine or naive Bayes or k-nearest neighbors or logistic regression or decision trees and random forests. All kinds of different options exist, artificial neural networks. So what we can now do is we start with the analytics goal. We map out the canonical tasks that can help us to meet that canonical, or to help us to meet the analytics goal. And then within each of those canonical tasks, such as classification, such as regression, such as clustering, we can further now map out the different types of algorithms that come into play. And you can see that in this diagram here. Now, how we compare algorithms, as I touched on previously. So typically in data science organizations, you have certain metrics, and there's a process by which you select the metrics based on your business requirements. When is it more important to be able to tolerate false positives? When is it important to sort of have high sensitivity to false positives, false negatives, etc.? So when do you prioritize precision over recall, over F1 score, etc.? So generally, selection of technical metrics is well understood in many organizations. But what we find is that when you go from prototyping or piloting or proving a concept to a production grade application, a lot of non-functional requirements also become very important. And what I mean by that is when you're training a model in a test setting using some kind of a notebook type environment, you're not really that worried about the compute cost. You're not really worried about, for example, cybersecurity. You may not necessarily be worried about model data shifting, model drifting, things like that, model management. But when you're going to now take something that you have built in a laboratory setting and put it into a production grade, customer facing, out in the internet kind of a mode, a whole new set of considerations come into play, which you may not necessarily have fully thought through as a designer or an architect of the solution in the piloting, prototyping, or proof of concept stages. And that has to do with this notion of soft goals or non-functional requirements. So for instance, when we have things like dealing with, let's say, the compute cost, dealing with the compute speed, dealing with the sensitivity to shifts in data, dealing with aspects of cybersecurity, these are all things that are very, very important in building industrial grade, mission critical, enterprise strength, production ready scale applications, but not some things that data scientists are sort of focusing on in the early stages of the exploratory experimental life cycle of the solution. But this is a framework that allows you to accommodate that as well. So you'll see here, for instance, they're comparing support vector machine with decision trees with naive Bayes. And you can see that as far as the technical metrics are concerned, there are certain traffic light indicators that with support vector machine, this indicator called sensitivity is a green light, but with naive Bayes, it's a yellow light, and with k-nearest neighbor, it's a red light, and things like that. But also you'll see on the other side, they have these quality criteria around overfitting, around numerical stability, around performance, around cost, etc. And so this gives decision makers and decision leaders, whether they be risk people, whether they be people on the investment side, or whether even they be the digital leaders in the enterprise, a much, much broader and a fuller and a more comprehensive depiction of the artificial intelligence system that is being designed and architected through this process. So very, very powerful framework. And what's very nice is I've used this term trade-offs a couple of times, because we know that when we are making decisions, inherently, most of the times in making complex decisions, it's not as though one option always is better than all other options across the board in every criteria. If that's the case, then certainly select that option. But when it comes to artificial intelligence systems, when it comes to data science, machine learning, quite often what we find is that you'll have some model that outperforms another model on certain metrics, but maybe not on some quality criteria, vice versa. Some model outperforms another model on certain quality criteria, but not on technical metrics. So what you'll see here is this notion of influence links. So you have these various technical indicators, you have certain quality criteria as well, all mapped out, but then you can see the types of contributions that are being made are different. Some are positive, some are negative, and this allows you to do a very robust trade-off analysis that then helps you to secure a stronger decision rationale that you can then articulate to your management team, your leadership team, to justify why it is that you pick this algorithm with this configuration of settings versus that algorithm with that configuration of settings. And remember, the nice part about this is that even when you're done doing whatever it is you're doing in the analytics design view, if you have done this part of the design right, it should plug very nicely into the previous view, which I described, which is the business view, which is, in other words, the higher performing your model is on technical and non-technical criteria coming out of the analytics design view, it follows logically that then the goals that you're trying to achieve at the highest levels from a business perspective also now have a better likelihood of success than perhaps had you chosen some other option that you've already considered and discarded through your analysis process. Okay, so here now, coming out of this, is the notion of what types of models we're trying to build. But as we always say in the business around data science and applied AI and machine learning, etc., is that we can't really have models if we don't have proper data. And now we get to the third part of the equation of this framework, which is the data preparation view. So in the data preparation view, this is when we start looking into our inventory of data assets, right? So we can start to say, okay, what kinds of databases do we have? What kinds of data do we have in those databases? What kind of schemas or what kinds of configurations or structures these data sets have? Can they be meaningfully interconnected? Can they be meaningfully interoperated? Can they be translated from one set to another set so that they can be then fed into a common machine learning pipeline, things like that. So the data preparation view is very technical, and this is down now at the data schema level, the database level, the data table level, and of course the data content level. And here what we're talking about is not just the stock or what we have, but also the flow. So streaming perspective. So when we have 5 different data sets in-house, we have 3 different data sets that we have access to from our partners that we're either paying for, or we have some other kind of public domain access to. That's great. That's all stock. But what I need is to be able to bring it together in a meaningful way and interconnect it, clean it, deduplicate it, fix any errors, fix any kind of issues that exist with it, and then feed it in a flowing pipeline way into my machine learning stack so that it can be used by these algorithms for meaningful model training. So all of that is actually depicted over here. And when you think about it from the role of a database administrator in the enterprise, this is things that they are already quite familiar with, is building out entity relationships or class diagrams, building, attaching notes and annotations, just so that for human interpretability, or in some cases, somewhat semi-automated machine processing, things like mechanisms as, okay, we have these data sets here, this is the content in these databases, but then to get them ready for training in a machine learning model, we need to do this step and this step and this step. So you can articulate not just the stocks, but also the flows. And now you can have a very, very good picture of the kinds of requirements you have and the current inventory you have of your data sets vis-a-vis their connection into a full machine learning pipeline or a data science portfolio that you're trying to develop. So this brings us to one of the most powerful facets of this framework, which is this notion of alignment. Recall that I started this presentation by talking about the value, the worth, the added value, as well as the value added of artificial intelligence and digital solutions grounded on data in the enterprise. And quite often what happens is that it becomes hard to sort of take a look at some of the exciting, experimental, exploratory systems we've built using AI technologies, but then map them back to the enterprise mission and mandate, map them back to the strategic priorities and plans. But when you see here in totality, if we followed the steps in a logical way, what we can have is we can have a portfolio of our data assets mapped to the digital solutions grounded in AI, grounded in machine learning, etc., related all the way up to the organizational mission and mandate. So the business view seamlessly interconnects with the analytics design view, seamlessly interconnects with the data preparation view. And as I've been mentioning throughout this talk, the nice part about this framework is because you can build this framework out in your own enterprise in a very sequential or a parallel, depending on how you prefer to do it, but more importantly, in a modular and a componentized way, what you can do is you can essentially start bottom up, or you can go top down. Bottom up is useful when you already have an existing repertoire of AI-based tools and systems in your enterprise, and you now need to map them to certain kinds of business objectives. So here you go. You can go bottom up, and you can take not just stop at the model level, but come all the way down to the data set level that feeds in to make those models happen, do what they do. You can also come top down. When you have certain insight needs or you have certain information goals in your enterprise that your current AI systems or data science tools are not currently meeting, then what? So you can come top down and you can use those insight needs coming out of your business view design to then populate the analytics view to understand the types of systems you want to build, eventually getting down to what kinds of data sets you need, whether you have them, whether you need to get them from a private sector player or a public sector player or something like that. So very powerful aspect of this framework is this ability to align the business view with the analytics view with the data view. Now, one of the nice things here I want to talk about in this framework is that to enhance adoption, because this framework can appear to be a little bit heavyweight, although it's not once you use it a few times. Something that the authors of this framework did to help industry practitioners adopt this framework and apply it in their enterprise is they came up with this notion of guidelines. Now, this is a very rigorous technical piece of work, which was the subject of a University of Toronto computer science PhD. So it's very scientifically precise. But sometimes what we need in the professional domain, in the industry, is some step-by-step help, some step-by-step best practices. And so that's what the authors have done. These are publicly accessible. We can find all the step-by-step details of how to take this framework, the knowledge in this framework, and implement this. And that's the notion of guidelines. Another thing that the authors have done, which is very useful, is the notion of catalogs. And these catalogs are pre-populated model fragments which have high reuse potential. In other words, when we have certain kinds of goals related to innovation or competitiveness or high-level strategic goals around effectiveness or efficiency, we find that in details they may vary, but at the highest level, these are the prerogatives of most modern enterprises. So what the authors of this framework did is they created this catalog of various different goals and decision goals and information goals and question goals, etc., that now practitioners can reference very quickly as sort of like a quick hint or a quick look guide, that when they are populating their framework in their enterprise, in addition to the guidelines which are telling them step by step how to apply the framework in their enterprise, they can now also refer to this catalog of pre-built content to sort of get some inspiration for the types of elements and modules that they're going to put into their framework as well. Now, when this model, when this framework is applied in an enterprise, this is kind of what a visual model looks like. This is a simplified visual model, but you can see it's starting with the decision goals. So there's some strategic goals and actors above this, but it's got decision goals, it's got the quality goals, it's got the canonical tasks, it's got the various algorithms, it's got the various data sets and the various tasks involved. So you can imagine now in your enterprise, when you have a framework like this diagrammed out, and you've got a nice depiction of the enterprise this criteria or strategy that you're looking at, then you can use this to go bottom up or top down and understand what it is that your enterprise needs to invest in, or how existing investments in artificial intelligence and data science are panning out vis-a-vis the top level goals of your organization. We can answer questions such as what ML can offer, what AI can offer, what algorithms are necessary for meeting canonical tasks, what types of analytics capabilities do we need, what kinds of data sets do we have, what kind of data sets do we need, etc. So very, very interesting set of questions that you can answer to rationalize and to convince and persuade decision makers in your enterprise about the worth or the value of certain of your portfolio of AI and data science solutions. So a framework like this is very helpful for eliciting and clarifying requirements, for designing analytics systems, for monitoring the impact of analytics systems on your business, for gauging and assessing alignment and fit within your overall enterprise strategy of the AI portfolio or repertoire that you have. And also you can address talent issues when you're trying to hire talent to do one type of data science work versus another kind of data science work. Then you can use this framework to also drive some of your HR strategic decision making as well. In our department, we've been applying this framework on a progressive basis to some of the projects that we've been working on, and we have certainly found that we've uncovered certain insights by applying this framework to our projects that we would not necessarily have covered had we only taken a technical lens to the management and the optimization of our portfolio. So with that, I'd like to conclude my remarks and would like to thank you for attending this talk in Forward 50. Again, a special thanks to Alistair and Rebecca for inviting me and allowing us to showcase some of the work we're doing at Natural Resources Canada in close partnership with the University of Toronto. But this is also my invitation for you to consider partnering with us, because if you are interested in building these kinds of framework diagrams in your enterprise, if you think that this will add some value to the type of work that you're doing, then feel free to contact us at this email address and also at this website, which profiles some of the projects we work on. And we're always looking to take on more partners. So thank you very much. And thanks again to Rebecca and Alistair at Forward 50 for bringing us together in this learning space. Thank you. Bye for now.
Thank you so much, Vic. Vic, as with our other speakers, is now going to move over to the Q&A room. So grab the link in the agenda that will take you to, if you haven't already been, that will take you to a platform outside of our event platform on a platform called Wonder, and you'll be able to follow up with Vic with any questions that he might have. And that's it for this channel. It has been an absolute pleasure to have you with us. We're going to be back on Channel 1 shortly with Pia Andrews closing out the keynote stage, talking about trust in digital government. So would love to see you there. Thanks again for joining us, and all the best.